All right, solving quadratic equations by graphing. So we have been working with quadratic functions already, and we know how to graph those. And a quadratic equation is just slightly different because it has the form ax squared plus bx plus c equals 0. And that 0 is the important part of that. Okay? Because instead of this being a function that gives us a whole curve, right, a nice parabola, it's now just a constant. It's just 0. All right, so we can solve this. We can find solutions to these equations, and the solutions to that quadratic equation are any values of x that make the equation equal to 0. Okay, and if we're looking at the function on a graph, right, the whole parabola shows us the function. If we're looking at the function on a graph, the solution to the equation is going to be those points where our y value is 0, okay, where they cross the x-axis. Those are going to be our solutions, okay? So let's get right into it. Our concept is solving quadratic equations by graphing. All right, we've already looked at kind of the difference. When we have a quadratic equation, right, that has this 0, we start by going backwards and we put it in terms of a quadratic function, right? Because if we're going to graph it, it has to be that function. It has to have a y and an x. But we know how to do this. Okay, we've been doing that. So we've already got our steps for how to graph a quadratic function. All right, and we start off by finding the axis of symmetry, or finding the vertex by using the axis of symmetry, right? So negative b over 2a. Okay, in this case, we have negative b, which is 2, over 2 times a, which is 1, right, times 1, gives us negative 2 over 2, or negative 1. That's my axis of symmetry, and I can mark that right here. There's going to be my axis of symmetry. Okay, so now I got to go back and find my vertex, plug in my axis of symmetry for x. If x is negative 1, I have negative 1 squared plus 2 times negative 1, then parentheses, minus 8. Negative 1 squared is going to be 1. 2 times negative 1 is going to be negative 2. And I've got my negative 8. 1 minus 10 is going to be negative 9, right? So that equals negative 9. Okay? So I've got my vertex on 1, negative 9, right there. Okay. Once I've got my vertex, I can go to find the y-intercept. That's the next easiest one. So plug in 0. 0 squared is 0, plus 2 times 0 is 0, minus 8. So negative 8 is going to be my y-intercept, my y-axis. There's my y-intercept. Because this is the axis of symmetry, I can reflect that over, and I can do that now, or I can do that later. I'm going to do that now. So I've already got my 3 points, and then you're going to choose a third value or another value for x to find that third point. I'm going to look at 1. Okay, I'm going to look at 1. So if I put in positive 1 here, I get 1 squared. We'll keep our parentheses, plus 2 times 1 minus 8. And now I've got a positive 1 plus 2 minus 8, which should give me a negative 5. So negative 5 and 1. 1, 1, 2, 3, 4, 5 down. There's my third point. Over 2 to the axis of symmetry, so over 2, reflect it, and now I've got my 5 points. and I can pretty much see where my parabola is going. I can kind of draw it. It's going to look something like that. Oh boy. Not a very clean parabola, trying to use the mouse, but you get the idea. And it looks like my zeros, right, the places where it crosses the x-axis, are going to be at 2 and -4. But because graphing a parabola is not always the cleanest, especially in here you can see it's not super clean, it's a good idea to go back and check. So if I plug in 2, excuse me, plug in 2 in for x, I should get 0. And if I plug in -4 in for x, I should get 0. So 2 squared is 4. And 2 times 2 is another 4 minus 8. Well, that equals 0. Okay, or -4. -4 squared would be 16. Plus -4 times 2 would be a -8. -8. And then minus another 8. Well, 16 minus 8 is also 0. So I've got my zeros. I've got my solution. Okay, the solutions for this quadratic equation, right, are going to be -4 and 2. Okay. One other important thing to remember is we won't always necessarily have these two solutions. Okay, because we're looking at the zeros, we might have two solutions. We might have just one solution if the vertex is on the x-axis, and we might have no solutions. Okay, so if you are starting your graph and you can see that the vertex is on the x-axis, you're done. That's going to be the only place it crosses. If you're starting and you see that you've got your vertex above the x-axis, and then you find a point that's above your vertex, has a greater y value, there's no way your graph is going to later come down and hit that x-axis. You already know that there's going to be no solutions. Right? Same idea if you have a vertex that's below the x-axis and then points that are below that. Okay? So you often get to the point where you don't have to graph your whole parabola. Okay? As soon as you find the zeros, you're done. All right?